Welcome back, viewers, to the Stellar Twin Voyagers program. Today, I, Nova A239, will guide you through another adventure of two siblings striving to explore their colorful dreams. Let's journey together through the eternal depths of time and fill our dreams amidst the sea of stars. Get ready to be mesmerized by the wonders of the universe and stories full of hope that will inspire us all. Morning has arrived once more, signaling the start of Aster and Cosmo's adventure, the shepherd siblings. The crowing of a rooster woke Aster, who was ready to learn something new on this new day. Cosmo, wake up, it's morning already, Aster said, gently shaking his younger brother. Let me sleep a little longer, I'm tired, Cosmo mumbled, still curled up. Come on, Cosmo, we can't be lazy anymore. It's morning already, let's go, we need to fetch water and herd our sheep, Aster urged, pulling the blanket off Cosmo. Alright, I was hoping to sleep a bit longer though, I'm still sleepy, Cosmo said. Aster smiled and, after Cosmo got out of bed, tidied up their room and hurried to meet their parents and grandfather. Good morning, father, mother. Good morning, grandfather, the two children greeted. Good morning, mother replied. Grandfather nodded. Father then responded to his sons, I slept soundly last night. Good morning to both of you too. Are you ready for today? I'll be back to help in the fields. Thank you for helping grandfather while I was away. No problem, father. If that's the case, we'll go fetch water first, alright, father. Aster said, then took Cosmo to get a bucket and ran towards the hillside well. There, the two siblings helped each other fetch water and brought the full bucket back home. We're back, mother, here's the bucket, Aster said, placing the bucket in the kitchen. Wow, thank you, mother said. We're going to herd the sheep now, alright, mother, father, grandfather. Cosmo said. Soon, Cosmo ran to the pen and opened the sheepfold door, and Aster guided their sheep out and led the flock to graze. It was still early and cool. The two children sat on a rock, waiting for their sheep to finish eating. Hachu, Cosmo sneezed. Are you cold, Cosmo? Aster asked. A little bit, big brother, Cosmo replied. Not long after, another, Hachu, was heard. Cosmo's nose started to run. You seem to have caught a cold. Let's head back home immediately, it's a bit chilly today, Aster said. Cosmo agreed, and together they herded their sheep, which had finished grazing, back into their pen and locked it. Father, mother, grandfather, we're back, Aster said. Only mother and grandfather were there. Is father at the fields, grandfather? Aster asked. No, your father is feeding the chickens, he'll be back soon, grandfather replied. Hachu, Cosmo sneezed again. What's wrong, my child? Grandfather asked, a little concerned. Aster explained, it seems Cosmo has caught a flu, grandfather. He's been sneezing several times since we were grazing our sheep. Is that so? Cosmo, come closer, let grandfather check your temperature, grandfather said. Cosmo walked over to grandfather, who checked his temperature, slightly high. Cosmo, you should rest at home today. My grandson, please take good care of Cosmo. Let grandfather, father, and Aster handle the work in the fields. Aster, are you feeling alright? Aster nodded, yes, grandfather, I'm fine. Cosmo, you just rest today. Once you're better, we'll work together in the fields again. Father's home, is there breakfast already? Oh, what's this? Your nose is red, Cosmo, father said. He seems to have caught the flu. I asked him to rest today, grandfather said. Father nodded, right, don't push yourself. Rest well so you can recover soon. But, I'll be lonely at home. At least I can sit in the hut and watch big brother, grandfather, and father work, Cosmo said sadly. No, Aster said, the weather has been getting colder lately, and you could make your flu worse later. You should rest well at home and take the medicine from mother. Cosmo still looked reluctant and disappointed. Don't worry, big brother will visit you often. You won't be too lonely. Read this book while I'm not here, relax, and rest, Aster said. Cosmo nodded. Alright, breakfast is ready. Let's eat first. After eating, Cosmo, go rest in your room, Mom will prepare your medicine later, said Mom. The family enjoyed their breakfast and finished quickly. Mom, I'm done, said Aster. Cosmo had also finished his meal. I'll take Cosmo to his room first, Mom, said Aster. Alright, let me handle the dining table, said Mom. Aster immediately took Cosmo to his room, covering him with a thick blanket to keep him warm. You'll feel better soon, trust me. We can play and work again with Dad and Grandpa. I'll leave you to rest now. Take care, said Aster, patting his brother's head before leaving him in the room. Mom, has Dad and Grandpa gone to the fields? Asked Aster. Yes, they just left, replied Mom from behind. Alright, Mom, I'm off, said Aster. Aster soon caught up with Grandpa and Dad in the field. Grandpa, Dad, I'm here. What are we doing today? Asked Aster. The straw here is dry enough. Let's start baling them into hay bales. We just need to compact these straws into the boxes we've prepared, explained Dad. Alright, Dad, said Aster, grabbing ropes and boxes for baling. He inserted horizontal and vertical strings, packed the straw into the boxes, and tied them up. Aster successfully completed the first hay bale. Good job, son. You've made better hay bales than last year, praised Dad. Thank you, Dad, said Aster, continuing to make hay bales with Dad and Grandpa. Although it seemed like a simple task, it took quite some time. Before they knew it, the sun was high in the sky, signaling it was almost time to stop for lunch break. Grandpa, Dad, I'll head home to get our packed lunch and check on Cosmo, said Aster, finishing his last bale. Dad shouted, no need to bring lunch here. Grandpa and I will also head home for lunch today. We'll check on Cosmo too. You go ahead. Aster nodded and ran home. Mom, I'm back. Dad and Grandpa said they'll be home soon too, said Aster as he entered the house. Mom nodded understandingly, and Aster quickly cleaned up in the backyard before heading to check on his brother in the room. I'm back, Cosmo. How are you feeling? Asked Aster, touching Cosmo's forehead. I'm feeling a bit better, bang. But my nose is still runny and uncomfortable, said Cosmo. Was it tiring for you to work alone in the field? I'm sorry for troubling you again, he added sadly. Aster shook his head. No, don't apologize. I feel very healthy and strong. It's not a problem. You just focus on getting better so you can help us in the fields. Cosmo nodded. Shortly after, Grandpa and Dad entered the room to check on Cosmo as well. Looks like you're getting better, said Grandpa. Let's eat first, Aster. Grandpa will continue the storytelling after lunch as usual, suggested Dad. Cosmo became a bit more excited. They quickly finished the lunch prepared by Mom, and Grandpa returned to chat with Cosmo in the room while Dad went back to the field to resume work. All right, said Grandpa, we've talked a lot about constellations and their stories according to ancient Greek mythology, although there are still many constellations I haven't told you about. Now, I'll explain a bit about what constellations are and some terms I've mentioned but haven't explained yet. So, a constellation is a group of stars that appear to form a pattern or shape in the night sky. The designation of constellations has been done since ancient times by various cultures, long before modern scientists mapped the night sky. Ancient astronomers, spending nights like we do, observed the sky and connected the bright points to form images known as constellations. However, stars within a constellation can actually be very far apart in three-dimensional space. In the early 20th century, the International Astronomical Union (IAU) defined 88 official constellations covering the entire sky. Each constellation has defined boundaries, so every star in the sky belongs to a specific constellation. I want to emphasize again that stars within a constellation do not have significant physical relationships with each other. They only appear close together due to the two-dimensional projection from our viewpoint on Earth. Physically, they can be separated by vast distances and have no gravitational or evolutionary connection. Constellations are more of a visual concept than a physical one. Now, you've heard of the term asterism, right? If a constellation is an area of the sky that includes a specific group of stars, designated by the IAU, and each constellation covers a defined area of the sky with official boundaries, then an asterism is a pattern or group of stars that is commonly known but not included in the official constellation definition. It's usually a smaller part of one or several constellations, used for identifying a constellation. A famous example of an asterism is the Big Dipper, which is part of the Ursa Major constellation. Now, about the basic units used in describing star properties. I've explained what an astronomical unit or O is to you before, right? But that's not the only unit commonly used in astronomical measurements. Today, I'll explain about light years and parsecs. First, the light year. A light year is the distance light travels in 1 year. Light travels at a speed of about 299,792 kilometers per second, so 1 light year is approximately 9.46 trillion kilometers. Second, the parsec. A parsec PC is a unit of distance used by astronomers to measure distances beyond the solar system. 1 parsec is the distance at which 1 astronomical unit, the average distance between the Earth and the Sun, subtends an angle of 1 arcsecond. 1 parsec equals about 3.26 light years. Are you still following along? Aster and Cosmo nodded. Grandpa smiled, took a sip of water, and continued, yes, earlier when discussing stars, I mentioned magnitudes and their distances. The distance part has been answered from my previous explanation. Magnitude is how we express the brightness of stars. However, there are 2 types of magnitudes, apparent magnitude and absolute magnitude. The numbers I used last night were apparent magnitudes. Apparent magnitude is used to measure the brightness of stars as seen from Earth. The apparent magnitude scale is logarithmic, where brighter stars have lower, more negative magnitudes. For example, the apparent magnitude of the Sun is minus 26.74. Of course, these apparent magnitude numbers can vary depending on observation conditions. Then there's absolute magnitude, which measures the intrinsic brightness of stars, or how bright a star would appear if it were placed at a standard distance of 10 parsecs from the observer. This allows for a true comparison of brightness between different stars. Absolute magnitude values are smaller than apparent magnitudes. I used a new term there, a logarithmic scale. Simply put, a logarithmic scale is a compact scale used to present measurements over a large range. Therefore, its comparison is not linear but exponential. Forget about that, you're still a bit young to grasp such concepts. Now, let me continue by explaining about stars, as stars are the main component in discussing constellations. A star is basically a giant ball of glowing gas, mainly composed of hydrogen and helium, which produces energy through nuclear fusion in its core. This energy is emitted as light and heat. One star you all must know is the Sun, currently shining upon us. So, stars form from clouds of gas and dust known as nebulae. This process involves 4 main stages, if I may summarize. First, condensation. The gas and dust cloud undergoes condensation and begins to collapse under the influence of gravity. Second, fragmentation. Simply put, the collapsing cloud forms smaller clumps, which then become protostars. Third, heating. As gravitational contraction continues, the protostar heats up and begins to emit radiation. Fourth, nuclear fusion. When the temperature and pressure in the core of the protostar are high enough, hydrogen fusion into helium begins, marking the birth of a new star. Perhaps I'll explain more about nuclear fusion as it is the basis of a star's activity. So, Aster, Cosmo, in a star's core, the temperature and pressure are so high that nuclear fusion can occur, which is the merging of atomic nuclei to form heavier nuclei. This process releases a tremendous amount of energy. In main sequence stars, the primary process that occurs is hydrogen fusion into helium through either the proton-proton chain or the carbon-nitrogen-oxygen (CNO) cycle. I may simplify it for you. First, there's hydrogen fusion. 4 hydrogen nuclei combine to form 1 helium nucleus, releasing energy in the form of radiation. Second, formation of heavy elements. When stars deplete hydrogen in their cores, they begin to burn helium to form heavier elements like carbon and oxygen. In more massive stars, this process continues to form heavier elements like iron. Third, end of a star's life. When a star's core is filled with iron, which can no longer produce energy through fusion, the star undergoes a dramatic gravitational collapse, resulting in a supernova for massive stars or becomes a white dwarf for medium-sized stars. However, Aster, Cosmo, stars aren't just one type. There are many classifications of stars themselves. First, there's classification based on spectrum. There are 7 types based on this classification. First, type O stars. These are very hot and blue stars, with surface temperatures above 30,000 K. An example is Zeta Puppis in the Puppis constellation. Second, type B stars. These are blue-white stars with temperatures between 10,000 to 30,000 K. An example is Rigel in the Orion constellation. Third, type of stars. These are white stars with temperatures ranging from 7,500 to 10,000 K. An example is Sirius in the Canis Major constellation. Fourth, type F stars. These are white-yellow stars with temperatures between 6,000 to 7,500 K. An example is Procyon in the Canis Minor constellation. Fifth, type G stars. These are yellow stars like the Sun, with temperatures ranging from 5,200 to 6,000 K. Sixth, type K stars. These are orange stars with temperatures between 3,700 to 5,200 K. An example is Arcturus in the Boötes constellation. Lastly, there are type M stars. These are red stars with temperatures below 3,700 K. An example is Betelgeuse in the Orion constellation. Next, Grandpa will explain about star classification based on evolutionary stage. But Grandpa needs a short break first, okay? Both grandchildren nodded, and while waiting for Grandpa, they read the book he had given them earlier together. Grandpa took a deep breath while sipping a glass of water, and after a short rest, he continued explaining, alright, first there's main sequence stars. These are stars undergoing hydrogen fusion in their cores. For example, the Sun. Second, red giants. These are stars that have exhausted hydrogen in their cores and started burning helium. An example is Aldebaran in the Taurus constellation. Third, blue giants. These are very massive and hot stars, short-lived, and consume their fuel very quickly. An example is Rigel in the Orion constellation. Fourth, neutron stars. These are remnants of supernovae, very dense, consisting mainly of neutrons. An example is PSRB 1919+21, the first neutron star discovered. Fifth, black holes. These are massive stars collapsing under their own gravity, forming a black hole. An example is Cygnus X1 in the Cygnus constellation. Then there are white dwarfs. These are hot cores left after the outer layers of a red giant star are shed. An example is Sirius B in the Canis Major constellation. Next, red dwarfs. These are small, cool stars with very long lifespans. An example is Proxima Centauri in the Centaurus constellation. There are also Wolf-Rayet stars. These are very hot and massive stars with strong stellar winds, rapidly losing mass and showing spectra with strong emission lines. An example is Gamma Velorum in the Vela constellation. Then there are pulsars. These are rapidly spinning neutron stars emitting electromagnetic radiation detectable from Earth as regular pulses. An example is the Crab pulsar in the Taurus constellation. Next, T Tauri stars. These are young stars that have just formed and haven't reached stable fusion balance. An example is T Tauri in the Taurus constellation. And finally, Cepheid variable stars. These are stars that vary periodically in brightness and are used as distance indicators in astronomy. An example is Delta Cephei in the Cepheus constellation. Well, that's it for the explanation of star types. But did you know that stars can also form systems where several stars orbit each other? As Grandpa mentioned before, there are binary star systems. That's what Grandpa meant. Both grandchildren shook their heads. Seeing this, Grandpa smiled and continued, alright, there are also some interesting star systems. First, there's binary star systems. These are systems where two stars orbit each other. An example is Sirius A and B in the Canis Major constellation. Next, there are triple star systems. These are systems consisting of three stars orbiting each other. An example is Alpha Centauri A, B, and Proxima Centauri in the Centaurus constellation. There are also variable binary star systems. These are binary star systems where one star transfers material to the other, causing variations in brightness. For example, Algol in the Perseus constellation. Lastly, there are cataclysmic variable star systems. These are star systems where one star is a white dwarf that pulls material from its companion star, sometimes causing nova explosions. An example is SS Cygni in the Cygnus constellation. Yes, that's all Grandpa's story for today. How about it? Interesting, isn't it? True, Grandpa, it's very interesting, Grandpa. Wow, apparently the stars we see in the night sky have many types, right, Grandpa? Isn't that amazing, Cosmo? Said Aster. Cosmo agreed, that's right, big brother, I feel everything is getting more exciting. I can't wait to finish reading all these books and learn more amazing things Grandpa told us. You have to be patient to read them a bit, at least Big Brother also wants to read them, but Big Brother doesn't have enough time to do it, Aster joked. They laughed together heartily. Alright, Grandpa will go back to the field first. If you're not tired, Aster, you can also join Grandpa and Dad to work back in the field, Grandpa said as he got up and left his two grandchildren. Thus concludes the Stellar Twin Voyagers for today. Enjoyable, isn't it? Would you like to hear more? Amazing stories from our young shepherds writing their stories among the stars. Therefore, stay with us on this program, and we will meet again in the next episode. In short, I am Nova A239, very happy to share stories with you today. Until we meet again, and let's continue to pursue our